Presenting Dev-Iterate, a platform which makes learning feel more personalized with the help of AI agents. I focused mainly on developer learning with smart quizzes, rich text content editing with TikTok, system design diagrams with Excalibur, and even a code execution service backed with Judge Zero. The complete execution of autonomous and AI agents is handled by Kestra. We've got really cool and large workflows orchestrated with multiple agents, which we'll be looking at today. We perform all sorts of stuff: RAG, web search, RSS feed summarization, with custom scripts, you name it. We even have Kestra flows as tools to subagents, subflows, etc., which I will explain in detail once we get a feel of what the platform actually does. Okay, so we've got a lesson section where we could view the lessons. Each lesson consists of multiple rich text blocks and diagrams which are powered by Excalibur. We've got a similar page but with system generated lessons which are generated by the AI agents running inside of Kestra. This whole rich text representation as well as the Excalibur diagrams are generated with AI. We can also manage lessons where we can trigger manual generation of content with the help of AI agents. Let's say that we want to come here and create a new diagram, and let's say we want to generate it with the help of an AI. A simple microservice architecture diagram. It says that it's generating it. This could take a moment while we are waiting for it, and yes, we could see the output of it. The title has been filled. We could come in here and save the diagram, and if we go back to Kestra, this is what it looks like. We could go to the executions, the current execution, and if we look at the outputs, the JSON output has a mermaid representation. The Excalibur takes the mermaid representation and converts it into custom elements, due to which we could see whatever is generated in the end. Yeah, this thing. And so we've got a similar flow for content as well, but the content generation generally takes a lot of time as there are a lot of inputs involved. So I would just show a pre-executed flow for it, where we essentially generate the lesson, which is again a JSON representation which is taken by the TipTap editor. We index the lesson and then we save it back to the database. And if we want to create this lesson, say GG, and we can see that the lesson is being created. The website also has an AI based personalized improvement section where I will come and trigger a workflow, and while it generates, let us look at the question corpus. We've got a question corpus for the learners to practice against, and after every 5 successful submissions or any sort of submissions, we generate an async flow that analyzes the questions and annotates the user's performance. Let's say this, we could come and practice against the questions. We also have many filters, and anyone can contribute a question as well. Let us go back to the personalization. We still have got analysis going on, but till it happens, let me show you what it actually does. This is one that was executed before. So what this workflow does is it takes the questions and the analysis and then it evaluates the learner. The analysis. So as I mentioned about a job that annotates the learner's performance, this essentially takes in the annotations via the webhook trigger and generates a novelty score via an agent. The novelty score is that the novelty score represents the amounts of new questions that each learner has to see now. Someone who has performed very well and someone who needs extreme improvement would want to have a larger corpus to practice on. So on the basis of the novelty score, we branch off with the help of the core branching features in Kestra and trigger the needed AI agent to do the generation of the questions. As we can see here, we checked the novelty and then we checked that the current user needed some advanced learnings, and then accordingly we triggered off the agents and then we saved the advanced questions. If we come and look at the outputs, the JSON output shows that it generated a novelty score of 8 and the learner category is advanced. Then we accordingly branch off to the generate advanced questions. It generates the questions and saved the questions. Meanwhile, let us try to go back and see, yeah, now the job has been completed and we've got a personalized question corpus to practice against. We could come in here and practice against the questions and we could see the correct answer and the approaches to guide us and help us improve more. We've got a similar flow for the personalized coding questions as well. Let us, while this job is running, let us try to go and see the coding section. We've got filters based on difficulties here. We could come in here and create a new problem. The problem creation could even be done with the help of a rich text in the problem statement section. We could come and define the public test cases, the private test cases, the limits, as well as the languages which it would be supported in. Let's try to come and solve a question. The question says merge two sorted lists, and let's see if we can. Let us try another one. This one is fine, sir. Let us see if we can submit a correct answer to this. I've got an already solved one. Let us paste that in and wait while the tests run. So essentially what is happening is the convex backend is calling a custom code execution backend which runs the test cases against a self-hosted judge0 instance. So we could see that the tests are being passed, and let us also try against a problem solution against which it fails. Let us paste that test and it should show us that it's a wrong answer, and it also shows us the past submissions. Let us go and check. Now the whole analysis of our coding problem submissions has been done, and we can again come in and practice specific questions generated for us according to our analysis. I'd also like to mention that the code editor here has been created with Monaco and our favorite cat Puccine theme. For the Kestra run of the personalized coding question generator, you could come in here and also look at the topology to be very similar to that of the personalized questions generator. Where it's a webhook, it would evaluate the learner, create a novelty score, and here as we can see it's creating a moderate level novelty and generating a general question set for us. Come and look at the outputs, where the evaluate learner output looks the same here, and the logs show us that the specific coding questions are generated as JSON and fed back to the convex database via HTTP actions. Now we've got all this going on and we still haven't gotten to the most interesting part yet, the system generated lessons. Now they mostly look the same, like you get it by now that we are generating some JSON with AI. So what's so new about this? This actually goes through these many Kestra flows in the backend to be able to show the end user a good visual representation. Now, these are very dependent flows. and generate a lot of tokens, and it would be very difficult to compress it inside of this video. So let us go through a high level overview of this. For understanding this, we first need to understand how our application works. Our application is basically backed by Convex as our backend. The client, Convex is a sort of a sync engine or a real-time database where the client queries and mutates the data, and it is very close to the actual database, and the developer experience is really cool. So the client talks with Convex. Convex pushes the automation jobs, the AI agent jobs, to the Kestra server via webhook triggers. Kestra in the backend communicates with the external systems, let's say the RSS feeds, OpenRouter as our API provider for the keys, for the AI keys, Tably web search tools, the vector database, etc. Now Kestra returns back the results to Convex via HTTP actions. Now Convex also exposes external endpoints which are known as HTTP actions, so that we could communicate in an M2M way. Now Convex also manages the responsibility of kicking off the code execution jobs, which are then given to the Judge0 instance, which is our self-hosted instance of Judge0. And then it responds back to Convex when it's done. One thing that you might be thinking is, how do we communicate this back to the client? Do we use WebSockets? We do not actually need to manually go and code WebSockets, because Convex internally does that for us, providing us a real-time sync with the database. So this is a high level overview of what the application is. Now for the main flows with Kestra, what we are essentially doing is we are looking to see what the users or specifically developers are interested in these days. We try to generate some sort of topics out of that, and we perform various sorts of searches. We search the web, we perform RAG on the user generated content documents that we are having. We also perform searches through the RSS feeds to get some sorts of summary texts back on the topics on which the users are interested. Once we get the summary representation, we then essentially create a representation of the rich text content as well as the Excalibur diagrams that we are having. So essentially, on a high level, these workflows are doing that. Now let's get into the more detailed part of how it works. So now that we get what we are trying to do, let us go into the detail of each subflow. So starting off with the topics extractor flow, what it does is it summarizes the top 10 Hacker News articles, and it creates the topics which the developers these days are interested in. If you would want to come and see here, the topics extractor, there is a Node.js script which fetches the top titles, and then there is an AI agent that generates the topics, and we send the results back to the database. Once we have the topics, then Convex via the webhook trigger calls the topics iterator workflow. Now this iterator iterates over each topic and then calls two subflows. One is the RAG flow and one is the web search flow. We perform on each topic. So each flow is essentially having the topic as an input. Now each flow is performing a different task based on the AI agent capabilities. The web search flow uses the Tably tool with Kestra's AI agent to perform web search on the given topic, as well as the RAG flow performs RAG on the user generated content documents that we are having is inside of the Convex database. And these agents then summarize that text and send it back to the Convex database and push it via the HTTP action, and it gets inserted inside the summary table. Now, there is also one other workflow which contributes to the summary table, which is the RSS summarizer workflow. What this is essentially it loops over a set of RSS feeds and then it summarizes each RSS feed, where it takes a custom Python script which is executed inside of Kestra, where we parse the representation, the XML string which is generally given out by the RSS feeds, and then we push it to a summarizer agent, and then we know the flow of generating the summary text back to Convex. So this is how we populate the summary table with a list of strings of the summaries of what the user might be interested in and the researched topics according to that. Now once we have the summaries, we create the system generated lesson titles via passing it to an agent that summarizes the summaries. Let that sink in for a while. Let me show that to you as well. Yeah. Once we fetch the summaries, we generate lesson titles. This is basically the agent which gets all the summaries and compresses it down and generate the end lesson titles for us. Then for each title, we run a subflow for creating the needed lesson content and diagrams. And inside of that looped over subflow, there is an interesting piece of Kestra. We've seen a lot of Kestra features today: agents, tools, RAG, web search, subflows from agentic flows, branching, custom scripts, and so on. But this one was really cool to me, as it lets you use Kestra flows as agentic tools, so that we wouldn't need to actually do the manual branching or flow controlling logic. That is, the agent could call the needed flows with the required parameters for us. So this then, let me show this really quickly to you. This looper then goes and creates the system, calls this subflow, and inside of this we have this creator agent, where we are passing the Kestra flows of generating the diagrams as well as the rich text representations as tools to this agent. And now this agent could then go in. Let me also show you one execution to actually show what I mean is that, yeah, this generates all the tool calls with the necessary inputs required. So we won't have to manually pass that in or parse custom JSON in the middle. And then those subtools then go and process all the logic for generating the content with AI, which we've already seen. And finally, we get a good representation, a good looking system lesson, which has all the required rich text representations and everything that we need. Custom diagrams, code blocks highlighting as well. Yeah. So yeah, this concludes my lengthy, but I hope worthy of your time presentation of what I've built over the week. It was really challenging to do a project of this volume inside of a hackathon, but big shout out to Kestra for helping me manage and speed up the development of the automations and the AI workflows. I've mostly covered everything in this presentation, but it's a big project. So do check out the GitHub repository for the code and a lot of Kestra workflows to use and learn from as examples. We'll update the repository with README and the architecture diagrams by the time this video goes out. Signing off, Ashutosh Bind.